Okay, example. What if we want to find the distance between two planes? Find the distance between two parallel planes. Okay, so we have 2x minus 3y plus z is equal to 4. There's one plane. And then another plane, 4x minus 6y plus 2z is equal to 3. By the way, how do I know they're parallel? What would be the normal vector of this first plane? We'll call it n1. What would be the normal vector? 2, negative 3, and 1. What would be n2, the normal vector for this second plane?
It's that, but it's n1 times 2.
Right, so 4, negative 6, 2. It's a, by the way, it's a normal vector. It's not the normal vector, right? And you can see that it is a scalar multiple. What you just said, it's a scalar multiple 2 times n1, right? n2 is equal to 2 times n1. So we know that the planes are parallel, right? So let me draw a picture for you. And in this process, we'll derive a formula for finding the distance between two planes. But keep in mind, you don't have to memorize that formula unless you want to. You can always derive it. It's not actually going to be that hard to derive. So let me see if I can draw two planes that at least kind of look parallel. Draw a picture of two planes that kind of look parallel. Okay, so there's one. Then the idea is this one's kind of underneath the one on top. Then, okay, let's do this. Let's take this normal vector down here. Suppose we look at a normal vector that points up like that. So this vector, this is a vector n from the bottom plane, although who knows if they're really oriented that way. It just depends on your perspective. Okay. And then let's suppose we stick a copy of this normal vector right under a point Q. So this is a point Q on the plane above. And suppose point P is any point in the bottom plane, so that we could form this triangle. We could connect P with the point just below Q, and then think of the vector PQ, like so. Then in terms of projections, magnitudes of projections specifically, can you tell me what the projection of what vector would get me the actual distance between the two planes, which would be this distance here, right? That would be D. It would be the projection of PQ, right, onto N. But that's a vector, so you have to take the magnitude of it, right? Does that make sense to you? Okay. Well, we have a formula for the projection of PQ onto N, or we stated it the projection of U onto V, but we do have a formula for that. Let me go back to green here. Remember, you take, okay, since we have magnitude bars, let's not forget those. Inside, the projection of PQ onto N would be, remember, PQ dotted with N over the magnitude of N squared. Remember that? And then you actually multiply that. That's a scalar right there. And you actually multiply that times the vector N. But because you're taking the magnitude of this, and the magnitude is going to split up, in other words, you can pull out a scalar as long as you remember to put absolute values around it if it's possible that it could be negative. So we'll put absolute values around the PQ dotted with n because the magnitude of n squared will always be positive. And the absolute value splits up over division, so that's okay. Then what's left inside if I pull this guy out, so imagine what I'm doing. I'm pulling this guy out. I can do that. I've got a theorem that says I can do that. Then what's left inside is the magnitude of this n right here. You see that? But now what's left is just scalar multiplication, or just multiplication of scalars, I should say. And so this guy, this magnitude of n will cancel with this magnitude. And we actually have a formula then for the distance. So this is the distance d. So the distance d then is going to be PQ dotted with n, okay, might have to be absolute value, over the magnitude of n. And so finding the distance between the two planes breaks down to this plug and chug formula. As long as we can find a vector PQ and find a normal vector. So how do we find a vector PQ? I didn't put any requirements on P and Q. They just have to be points on the opposite planes, right? So if you're given an equation of a plane, in this case, two equations of two planes, you've got an infinite number of points that lie in those planes given by those equations. Just pick the easiest ones you can think of. If they exist, pick an intercept, an x or y or z intercept. So think about it. If I plug in, say, 0 for x, 0 for y, what do I get for z? 4. So 0, 0, 4 lies on this first plane. So I'm going to call my P 0, 0, 4. Now let's find a Q. Let's go back up to the other plane. Okay, let's just do the same thing. I don't see any advantage in finding any other. So I found a z-intercept before. I'll find a z-intercept again. Plug in 0 for x here, 0 for x here. What do you get for z? 2/3? 3 halves, yeah, 3 halves. So 0, 0, 3 halves. Does everybody see how I got those points? Okay, so now back to what I was talking about. We're going to look at this formula and plug and chug into this. But first, what does this formula tell us we need? Well, we need, yeah, but before that, don't we need a PQ? A vector PQ? Yeah. Okay. So take essentially Q minus P, right? Respectively. And what do we get? 0, 0. What's 3 halves minus 4? Well, 4 is what, 8 halves? So negative 5 halves. All right. That's not so bad. One little fraction won't kill us. Does that make sense? Okay, which normal vector do you want to take? Doesn't matter. They're both the same, right? I mean, they're scalar multiples of each other. So how about the one with smaller components? 2, negative 3, 1. So n, 2, negative 3, 1. Okay, now that we've found this stuff, it's just a plug and chug formula, right? In fact, I'll go ahead and separately find the PQ dotted with n. What's that going to look like? That's pretty easy, right? 2 times 0, 0, plus negative 3 times 0, 0, minus 5 halves. Oh, that's why we need those absolute values. Is that okay? So PQ dotted with n is minus 5 halves. So our distance then is going to be the absolute value of negative 5 halves. Yeah, the distance better be positive. Over, oh, I didn't find the magnitude of n. What's the magnitude? I'll do the magnitude separately. What's the magnitude of n? Square root of 4, 2 squared, right, plus 9 plus 1, which is root 14. So we get this, which, if you take the absolute values, you get 5 halves, but you could write it like this. Oh, root 14, sorry. You could write it as 5 over 2 root 14, right? So think of writing the fraction 5 halves out in front and then multiplying, you get the 2 in the denominator. That works. That's our distance.